Hello guys, welcome to my YouTube channel. This is my first video on my YouTube channel. I just randomly got this idea, okay, I should just record something on my YouTube channel, start my YouTube channel. At this point, I haven't even decided the name of my channel. Anyways, thanks for coming here and this phone, I'm going to use it to post lots of educational content as I grow in my career, what all the things that I'm learning day to day basis. It could be anything related to tech, anything related to DSA, system design, research paper that I read, or some interesting, topics on the AI field, how it's evolving and how I'm evolving in my career. So it's just going to be like a documentation. Thanks for joining this space. Follow along. I hope you also learn something from this space. Anyways, to keep things simple, I just thought of recording a LeetCode tutorial solution. So I picked just the daily problem today. So let's dive right in. Right? So today's LeetCode question is 1967, number of strings that appear as substrings in Word. It's a easy category problem. Given an array of strings pattern and a string word, return the number of strings in pattern that exist as substring in Word. They have also given the definition of substring. So these are the words which is given in the patterns array, and the word that we were given is ABC. We need to find which of these strings and how many number of these strings exist as a substring in here. So let's first discuss what are the substrings of ABC. So ABC substrings are uh, A, AB, ABC, BC, and I think C. A, B, oh, I must B as well. Okay. So these are the substrings of ABC. If I have to, let's forget about coding and programming, all that part. If I have to ask you like manually, how will you give me the number of words that matches? What would you do? You pick the word and you scan through the eyes that which of these exist as a substring. So is A substring of ABC? Yes. Is ABC substring of ABC? Yes. Is BC substring of ABC? Yes. So we have three. Is D a substring of ABC? No, D is not a substring. So the count is three. Okay. Uh, Before you solve any problem, I would recommend look at the constraint as well, because this shapes how optimal is the solution expected. Okay. So let's discuss about the time complexity of the approach that we had. What we did, we picked up individual words from the patterns array. Let's say if the patterns array length is P. Okay, P is the length of patterns array. Um, and what we did is we iterated through word. Let's say the length of word is W. When you are doing the substring matching, so the substring pattern matching uh, by brute force, the time complexity that it takes is the length of the word cross what is the length of the substring. In here, the worst case, let's take the substring length to be W. So our pattern matching algorithms brute force time complexity would be W cross W. So the overall time complexity would be P cross W. Why? Because we pick up each of the word from the pattern and try to find the substring, and if it is present, then we generate it. So this would be the worst case time complexity. And if we see here, right, we have like 100 and these are 100. So at max it is 10 power 6. So it's all right. Even the brute force works. But there is okay, before I code this brute force, you need not actually go through and write the for loop. Rather, there is a STL library that we could use which says text.contain. So you just pick the word and put like if the word dot contains of this pattern, then it just returns true or false. We could utilize that. This would be the solution that I would be coding. But there is one more optimization that I would like to do. That comes clear in the third example. Let's say in here all the strings are unique. So it makes sense to iterate over it one by one to find how many numbers does it contribute. But if you see in here, what we are doing all three times for the same string, we are going and doing the pattern matching. So basically, three times of W cross W we are doing. Rather, we could just, instead of three times of W cross W, we could just optimize it just once. Okay. So how can I do that optimization? To optimize this, what I'll be doing before I start the string pattern matching process, I'll just store the number of occurrences of each string in the map. Okay. So by this way, I'll be reducing to some level. Okay. So let me start coding. So what we need to return, we need to return the count. Okay. Now, where I mentioned that store the strings and their occurrences, right? We just want to process it for the unique instances rather than for everything. So what I'll be doing is I'll be declaring a unordered map, which is for every string, how many occurrences of it are there. Okay. So for every uh, word in the pattern, I'm feeding it into the map. Okay. So for every individual strings in the pattern, I'm just tracking the count of it. Now, for all the instances in the pattern. So right now, my map array would be looking something like A would be 1, and then for the first example, I'm saying ABC would be 1, and BC would be 1, and D would be 1. If I take for the example 3, right? Example 3 would be something like A would be 3 occurrences. So this would be the contents of my map array. So when I'm getting into the processing, I'll just process for the elements in the map. I don't know if I said map array. I shouldn't have said the map array, just map. Okay. So when I'm processing for all the elements in the map, you know how the maps are ordered, right? They are ordered like the first, and this is second. So I want to match for the first. This is the word that I have. So what I need to check for the word, I need to see if word contains my x dot first, which is element of the map, and the first part would be the string if it contains the string. If it contains the string, I want to increase the counter by how many number of occurrences of that string occurs. So if I am doing it for ABC, then I would increase by 1. If I am doing it for A, then I need to increase the counter by 3. Okay. So I'll be doing x dot second. So this would be my entire code of this problem. This is a fairly simple problem. And yeah, let's just check quickly if it completes. Let's just run it once. Okay, all the cases passed, and let's just submit it. Yay! That's the first submission and first submission of our YouTube channel. Okay. Before I wrap up this video, right, I'd like to also mention, so this is a pattern matching problem. Now, the solution that I provided is W cross W. The most common algorithm in pattern matching is KMP algorithm. You could also solve this problem in KMP with KMP algorithm. That would reduce the time complexity to linear. Okay. So in here, let's say the length of the string is, the word string is say W, and the length of the substring is taken to be say N or something, then it would reduce the algorithm to W plus N. Okay. And if we take the length of the substring in the worst case to be W, then it would be W plus W rather than W cross W. This is like a standard pattern matching, which is brute force. Okay. Whereas the pattern matching of KMP is optimized. Why I didn't use KMP algorithm for this problem is because of this constraint. This is so small, so I don't need to go over there. But let's say if the word length was 10 to the power of 5 or something, without any thoughts, without any second thoughts, I would directly go to the KMP algorithm. Okay. So from what I believe, I think since it was asked in weekly contest, it is asked as a first problem with brute force. And then usually LeetCode, they ask the second problem with same description and everything with larger constraint. I think that's what they would have done. Anyways, if that is the case, then we will solve it in a different problem. Okay. That's it for today. My first YouTube video. I don't know how it went. Drop in your comments and tell me how it went. Welcome to my YouTube channel. Bye.